I have a second channel, Cube Comp MTDX.
Hey everybody, so here we have yet another laptop battery. This is, I forget how many I've done so far, quite a few over the past week, and they all had bad cells, either cells that were nearly dead or completely dead, or cells that had low capacity and or were heaters when you went to charge them. So here we have this Dell laptop battery. It's out of an older Latitude laptop. Now the thing is, this one, you can see it's apparently it's dead, but this is actually a generic replacement, so it's not a factory OEM battery from the computer it came out of. So we may have a chance with this one. This one's newer, so maybe this one will have somewhat decent cells in it. So it's 11.1 volts, 49 watt hours, and this one don't specify the milliamp hours, but when you do the math, you essentially take this 49 watt hours, you divide it by 3.7, so 49 divided by 3.7, no, excuse me, 11.1, yeah, the pack voltage, 11.1, and that gets you 4.4, which is essentially 4,400 milliamp hours. So if we divide that by 2, since this is a 3S2P pack, that gets us 2.2. So we theoretically we should have 2,200 milliamp hour cells in this. Now the thing is with generic replacement laptop batteries is sometimes, or a lot of times actually, the cells that they put in are not the capacity that they specify on the label. I've seen this very often actually. The cells generally are good, they work, but they're just not as high capacity. Now these generic replacement packs, they've been hit or miss for me. I've gotten some good cells, and I've gotten some bad cells. Some of these packs are not built the best. Some of them can be actually a fire hazard. I opened one apart a while back that actually had no fuse in it, which they're supposed to, generally they're supposed to have a fuse in them. So anyways, enough of the talking. Let's go ahead and crack this one open. So if we peel this label back, you'll see we have cells, and these look like a brand that I have dealt with before. They got the ASO on them and the SZN. Matter of fact, these look really similar to the cells I harvested from a pack. It was that 9-cell pack I harvested. I want to say 2 years ago, something like that. I took 8 of the cells and put 2 each into these power bank kits, and 1 was left over from my flashlight, so they're still holding up well. Now the thing is with these replacement laptop batteries, they can be a little hit or miss getting into. Some of them are easy, some of them are difficult. Now this pack here, I should mention, we gotta use some caution with it. Because a lot of packs that I've harvested, they had the cells, like for example, 2 here, 2 here, 2 here. This one, however, we have 2 here going this way, 2 here going this way, and 2 here going this way. So we got a positive up here and a negative back here. So, and also the thing is with these, they, in addition to having, of course, the conductor for the positive or excuse me, the negative or the positive, we also have an extra conductor running along here as the balance connection. So we gotta be careful to make sure we don't short those out. So it's gonna make this pack a little more challenging to get into. But again, considering this is a generic replacement, we may get an easy ride with this one. So I'm going to actually pry into this area right here, since this is a negative, and we shouldn't have any other conductors right here other than a negative. Let's see here. Sometimes I'll use this knife to try to start my way into a pack. Just gotta be really careful with it though. For one, you don't end up stabbing into a cell or a conductor inside the pack. And also you don't stab yourself. Whichever you consider more important, that's up to you. Sometimes once you can get these things started, they get quite easy. So what I may do here is I'll just, oh, here's a spot we can actually break these off. So one thing I do love about generic replacement laptop batteries is they're usually a little easier to crack into than name brand ones, like OEM ones. Yeah, we should be safe to pry into this side over here. So I should mention, it's important that when you're cracking into a laptop battery like this, that you keep a watch out for smoke, sparks, and keep an eye on the cell temperatures. If you feel anything getting warm, you're shorting something. And if you see smoke or sparks, you're shorting something. Okay, so they got looks to be Kevlar tape insulating the conductors. Let's hope they got more than just that. I would think up here in this area. I would hope at least. So it's very tightly packed in here. This will be my second time opening up a Dell pack like this. The last one I opened up was a genuine Dell pack, and it was similar to this. I did that one outside because I was so nervous opening it up. Anytime you're going in and pulling up on these pieces, you gotta keep an eye out for conductors or any other components that might be below the surface. So here we have a thermostat. Okay, the battery had went dead on me during the video. So as I was saying, right under that piece of plastic got this thermistor. So you gotta watch out when you're digging in and working with this kind of stuff. And here's something that I think is definitely worthy of some attention. I just noticed a loose piece of solder right here, right next to where this wire is soldered in. Yeah, as I think I mentioned, some of these generic replacement laptop battery packs they're just not put together really well. Yeah, that's for certain. So we'll just continue working our way in here. I guess another thing I should mention is when you're digging into these things, you gotta be especially careful where there's any connections involving the positive, because a lot of times they'll wrap around. A lot of times they'll wrap around like this, and it appears this manufacturer, well, they use some of this tape here, but they didn't use hardly anything more than this cell wrapper, and that's not something I much care to see, because all it takes is a small puncture in the cell wrapper, and you could have a short on that cell or that bank of cells. Now this here is actually negative. This is a negative side, so that's not the case over here, but on the positive it is for sure. And when you're tearing the nickel strips off the cells, you gotta watch for that too. So we'll continue working our way into this pack. And sometimes you may come across a point where you have to introduce your pliers on the positive side of a cell. You just gotta really watch what you're doing in that case and make sure you're not bridging any connections between positive and negative. Yeah, this battery pack has an L-shaped circuit board. And we got the plastic off, so here's the cells. 6 of them. Now last time I harvested these the cells like this, the purple ones, they were really good. Now the pack was still healthy. It was still working. The computer it was in, different story. But the pack was still good, so all 9 cells out of it were good. As mentioned, I got them in these power banks, and if I remember correctly, they were charging up to like either 2200 or maybe 2400 milliamp hours. It was actually a really good number. Here's one of them cells. This was the 9th spare that I had out of the pack, because of course 4 pairs went into power banks, and the remainder, this last one, got used as a flashlight cell. This one has actually been rewrapped, and you can see they look exactly the same. And it's funny, yeah, the cell wrap is exactly the same purple. Well, go figure. The cell wrap I bought off Amazon, it came straight from China, so that's a real shocker there. They probably these cell manufactured in China. They probably just have a standardized set of colors that they'll use. Okay, so let's see if we can lift this out of here. Just watch for short circuits as you're lifting it out. So, as I was saying previously, on this side of these Dell packs, you gotta watch, because they have, in addition to your negative, I think it's a negative. I can't tell. I'm having to look here and see exactly how this is wired. I want to say it starts from here and works its way around. So you have this negative wire starting to the whole pack over here. This negative conductor starts over here and goes here, here, and here. And the thing is, you have a second conductor going from these 2 cells to these 2 cells, and there's just a thin piece of insulation separating the two. So you got to be extremely cautious hacking into one of these packs. You just got to take your time with it. So what I'm going to do is I'm going to begin isolating this circuit board from the pack. That way I can get this pack disassembled. This is the kind of one you want to disassemble kind of like right away, if possible. So, I should mention this pack does have the proper fuse. There's a fuse right there. There was one pack in the past where I saw that was where they just put a wire there, and that's just ridiculous in my opinion. Because you think about it, that fuse could be the last thing that would stop, the pack from catching fire. And they chose to completely just bypass it. Just save a few cents. So I can't necessarily say I wouldn't recommend buying a generic replacement laptop battery. I mean, I still buy them. And in fact, for older laptops, it may be all you really have. But I try to spend a little extra money on one. Don't buy the cheapest one you can find. I think as long as you follow that kind of strategy, you should be okay. So I'm going to go ahead and disconnect this positive wire right here. Be careful not to cut into this paper or the cell wrap. Alright. And also we'll disconnect this balance wire. I'll disconnect it right about here. And disconnect this balance wire. And I will carefully pull away this strip. Okay. And I'll just go ahead and pull that off the matter of fact, yeah, what I'll do is I'll just snip it just for the time being. Okay, so we now have the circuit board isolated from the pack. Yeah, to be honest, a lot of times I would actually check the voltage first before I start disassembling, but in this case I wanted to get that circuit board off of there and make sure I had that that negative strip away from this connection here. Alright, so let's see what the pack voltage is, see what we're working with here. Now, as you've seen in the beginning of the video, none of the lights lit up on the controller. So, now sometimes when that happens, it's simply because the pack has gotten below the minimum threshold, or the pack is either dead or it's well below the threshold. Alright, let's see here. We have 7.3. We'll call it 7.3. 7.29 actually. Alright, this bank of cells. .84. This bank of cells we have 1.99. So we'll say 2 volts on that pair. And on the last one, 2.45. Okay, so these cells are at minimum 2 volts, 1.99 roughly. So what's happened is this pack has sat for a while and it's just gotten below its threshold that the charge will even, the circuit board will even accept it. So that doesn't mean these cells are bad. since they're all nearly the same voltage and they're right around 2 volts, I think it's pretty safe to say that they can be revived. My Opus charger is actually really good at waking up cells that have low voltage on them. Now, in a case where, like some of my most recent pack harvests, you'll see where 2 pairs of cells are sitting at like 3.6, 3.7, whereas one pair is either at absolute 0 or a real low number like 0.5 or 1.5, something like that. Now, in that case, the cells that are sitting at that low voltage, I'll reject them right away, because chances are they're bad. But in the case where all 6 or all 3 pairs in a 3S2P pack like this are all sitting up at about the same voltage, it's more likely the pack has set for a long time, and it's just the circuit board with time will eat some power. That's the only thing I don't like about BMS circuits like this. They tend to eat power. Same goes for individual cell protection boards. So what we'll do is we'll tear apart this pack. And we'll do a separate video on the cells themselves. So I'll start out by just pulling this nickel strip off. Now, since this manufacturer chose not to, let me see, yeah, they chose not to put these in. They chose not to add insulating discs on the tops of the cells. Be careful, because sometimes all it takes is a little bitty hole in that cell wrap. Your pliers can create this. Your pliers can finish the circuit. That happened when I was actually harvesting cells just like these from that 9-cell battery pack. Had a little bitty puff of smoke come up, which told me right away that we had a short. Now, on the negative side, you're generally okay. You just the thing about the negative side is you want to try not to puncture the cells. Now, with most laptop batteries, that's not going to be too much of a problem, because they tend to use really thin metal, and also, not to mention, the spot welding is generally not that great on these things, on these generic packs, because of course it's a cheap pack. So I think we'll come back to that piece and get that off later. But so here we are coming up to a positive. Another thing you should be careful about is getting any loose metal inside the disc, this white washer, because right below that is the separator for positive and negative. So I'm actually going to cut these right here. That way I'm not dangling the whole pack around. I'll come back to these here. We can peel this off now. I'm just got to be careful here. Yeah, I much prefer when cell manufacturers, or pack manufacturers, excuse me, go the extra mile and put insulating disc on the positive strips, or the positive sides of the cells, because it just it makes it safer. You don't ever have to worry about the negative, or excuse me, you don't have to worry about the top of the cell shorting out against itself. Another thing to mention is be careful with this metal because it's very sharp. So when you're tearing into a cell like this, and you got a little bitty piece of strip left in a corner, which I've already peeled off, it's a really tiny piece. You gotta be careful because you don't want to fall down the side here, because just below this washer, as I think I mentioned, is you've got this right here. This is a naked version of this cell here. And you got this white insulating disc. So right there is negative, right there is positive. All it takes is a little bitty piece of metal to bridge between the two, and you have a short. So it's important that you take care when you're removing these as strips. Okay, everybody, so now I have all 6 cells numbered. They're ready to be tested, so I'll be following up with a separate video on testing these cells. We'll see how they do. So anyways, hope y'all enjoyed this video. Thanks for watching. Well, everybody, that's it for this video, but don't forget there's a lot more interesting stuff on the channel to check out. Also, if this is your first time visiting this channel, feel free to subscribe to keep your channel, and also don't forget to tick the bell so that way you'll get notified of new video posts. If you like this video, please give it a thumbs up. But if you really didn't like it, there is the alternative option available as well. Also, feel free to check out my second channel, CubeComp MTDX. There you'll find videos about bicycling, weather, elevator tours, and all sorts of other neat, interesting stuff. I hope you guys enjoyed this video. Feel free to come back, and thank you for your support.